The AI revolution isn't replacing Java developers. No, it's forcing us to think harder.
Give me a foo, give me a J, give me the friends of OpenJDK.
Welcome to another episode of the Foojay Podcast. Today we're talking about AI and Java, how it's changing the way we work, what we need to watch out for, and why understanding what's really happening matters more than ever. I recorded these interviews at Devoxx and JFall and talked with people who are actually building and using this stuff every day. Marianne Hoornenborg opened my eyes to something important. Every time an AI generates a token, there's a massive amount of computation happening behind the scenes. She's talking about billions of floating point operations, and all that computing power uses a lot of energy. Viktor Gamov and Baruch Sadogursky did something really cool. They tested 6 different AI coding tools live on stage with the same task. The results were all over the place, but they found that the tools with access to good documentation performed much better. Stefan Shin showed me how graph databases can make AI responses more reliable by providing a solid source of truth rather than relying on vector search. Mario Fusco works on LangChain Foojay, a leading Java framework for AI. He explained that breaking down large tasks into smaller ones and using specialized agents can help reduce hallucinations. Jeroen Benckhuijsen and Martijn Dashorst shared their experiences working with enterprise Java. Even though frameworks are becoming lighter and we are running everything in containers now, there are still complex problems that require real developer expertise. Maarten Mulders reminds us that AI is a tool, not a replacement, especially when you're solving problems no one has tackled before. You still need to know what you're doing. And finally, Simon Maple from Tesla discussed moving beyond vibe coding towards a more reliable, production-ready approach using specifications to guide AI tools. Let's get started.
My name is Marianne Hoornenborg and I'm an attendee since 1 o'clock, but before that I was a speaker at 12 o'clock. And I'm also an NL lead, so I enjoy seeing the conference here and comparing it to what we do in Holland.
Okay, comparing is better here?
Different things are better, other things are better in JFall. So yeah, there should be differences in conferences, right?
Okay. You are a speaker, so you have a talk. What was the subject?
My subject was the simple math behind AI. And I fell into one of the pitfalls that many speakers do. We say AI and we actually mean generative AI, and simply put, the mechanics around large language models. Whereas I think we are ignoring so many opportunities of AI that I don't feel are addressed enough today. But what I wanted to do was to make comprehensible that at the core of the nodes in a neural network, it is simple computing that's happening there. It's just on an enormous scale. And if you start realizing how much it costs in computing force for every token that gets generated, it's extreme.
Simple math? Is it really so simple?
In my presentation, of course, I skip through a lot of layers of complexity. Many of them are especially around scale. So at the core, it is really multiplication and addition done with a large set of numbers represented as vectors and matrices, but they're just shapes of arrays, right? So we know arrays. The other complexity is in the choices that are made around certain activation functions, and 2 subjects that I didn't address around attention and temperature. So you're right, there is more to it, but even those mechanisms are pretty well explainable if we focus in on them.
Okay. You touched the complexity of the hardware which is needed to do all this. Hardware means cost, means electricity, means it has an impact on ecological things. Do we use AI for all the right tools?
I don't think so, no. And part of that is also because we are focusing on the generation of stuff. And I hear in all talks that AI-generated stuff is not always that good. So we have to review it and we have to work on it. But if AI keeps producing so much, there's an energy cost to the generation of it and an energy cost to the upkeeping of it, right? So I think in both sides, we need to focus a lot on where our energy is going, literally. I am dreaming of AI that is taking things out of my landscape that is not useful anymore, and taking away legacy systems that are only still in use by one small component somewhere. That's what I dream of.
Are we as developers responsible? Should we think more about the impact that we have with our code on ecological, on electricity use, on hardware use?
I think I should leave that to others because I don't know the computations on the carbon footprint. I can imagine that there is development in hardware to make it more energy efficient. But I do think if you realize for us to think of one word, we're doing this all the time, right? And energy-wise, it's very efficient. And I think we compare AI too much with our own text production ability. And if we realize what takes place when generating just one token, just the massive amount of computation. They're called flops. Did you know that? Yeah. Floating point operations. So they're into the billions of flops for each token generated. And then, well, you have more respect for the human brain, right? And the capabilities. And then I think like, well, let's produce our own text.
I think in IntelliJ, if you do a request with a chat-based interface, you even see how many tokens are being used. So you make me very scary now.
Well, you could be or should be. So we compare it to human interaction and human text production, but because it feels intuitive, but it's just massive computation underneath. It's just brute computation used to force produce every token time and time again.
If there's one thing people should remember from your talk, what is it?
I think people should stay curious and zoom in onto the details of something, especially when something gets mystified, such as AI.
This is Baruch Sadogursky.
And this is Viktor Gamov.
And this is how we do introduction to each other during our pair talk as well.
Okay. Because, you know, it's not polite to pump yourself, so we pump each other.
Yes.
You have a talk. What's the subject?
Subject talk calls robocoders and agentic ID face-off.
So the idea is that we get a bunch of tools as much as time allows. And yesterday we had a 3-hour slot. So we brought 6 AI agentic tools and gave them exactly the same setup, exactly the same prompt, and just waited to see what happens.
Yeah, we try to show how different tools can provide more or less consistent results based on consistent methodology. So we introduced few methodologies that people can apply for their agentics, because sometimes people find themselves very confused and a little bit frustrated with the vibe coding things, because the system is not giving them result what they're expecting. And this is also expected because you put in garbage as an input, you're expecting to get something nice, but you're actually getting garbage as output.
And we can do better, right? So there are different tools that have different model massaging, what we call, like all the system prompts and pre-processing and post-processing. So there you will get different results by using different tools. But you can also use different models, and not all models created equal. There are smarter models, there are models that just catching up. And you can also apply methodologies to how model works. Yeah. And you can instruct it to pay attention on different things, to do the right thing from the beginning. For example, you can use test-driven development, you can use behavior or spec-driven development, you can verify what the model does in different ways. And the fascinating thing is that having the exactly same prompt, that was kind of a premise that you will use the same prompt, but everything else was different, and we got vastly different results, which was fascinating to see for us, because we obviously didn't rehearse it. And it was fascinating to see for the audience, because they didn't know what to expect.
And what was the best one? So you had 6 different approaches.
Everyone wants to know what's the best.
Yes.
You need to watch 3 hours video. I'm just kidding. So what the winners? Surprisingly, we found ourselves in a very interesting position, because in the past, when we're trying to do this like a live coding, and it usually takes some time, and iterating over certain things will take some time. And in this particular situation, our winners just spent first 15 minutes, and after that they were done. The application was ready, and all the specifications were, implemented. So we found that JetBrains Juni did amazing job. We found the Kiro from Amazon did amazing job, and also command line tool Claude Code did amazing job. Like for first 15 minutes, we spent a little bit more time on Kiro, just explain the approach with the spec-driven development. But in general, that's what we have. That's the results. But to be honest, we put this other ideas in slightly more constrained environments. We use slightly less research models, I would say.
Yeah, so the winners all had an advantage of having the most advanced models. So Claude Code uses Sonnet 4.5, which is amazing. Juni uses Sonnet 4.5.
No. On the Juni, we expected this to use Sonnet 4.5. We actually used GPT-5 because... By mistake, because with the recent update, the JetBrains put this GPT-5 as a default model, and it was still surprisingly how good it was. Comparing to what we try to do with like GPT OSS and some like local models, the hosted models are just amazing.
And the others were we would put them in a more constrained environment. So we tried, for example, the new Grok coding model in Visual Studio Code, and it did what it could. It's just a younger model; it still has to learn. So that's why it wasn't as impressive. We tried Codex with obviously GPT-5, and I switched it to thinking mode, and it wasn't the thinking process, the reasoning was very impressive. It just took too long. It didn't finish on time. By now, I think our takeaway from this, we need a more complicated app to really challenge the top tools out there, like your Juni, your Sonnet 4.5. Our app is just too easy for them by now.
So even though this app was not something kind of like go write a microservice, we wanted to have like something a little bit challenging, a little bit unknown. So that's why it's a combination of IoT and microservice and a little bit of front end and doing some interesting things interacting with the webcam. So essentially, on the webcam, we can read the color from your T-shirt and the light bulb in the room, so that will change the color that matches your T-shirt. So that was the idea.
Not trivial, right? It has some moving parts. It has APIs that the tool need to research and what's not. And in previous runs, we started to do this talk. I think probably like 8 months ago. It was enough. It was challenging enough. Now it's not. We really need to up the game and come up with something more complicated.
These models are trained on existing code, which it can find online. I have very good experience with asking questions for Java, Vix, Vaadin, stable technologies. It's only when you start experimenting with the latest Java 25.
It's a perfect.
We have an answer for that.
Is that a challenge?
It is. So the way how I started, I got get into this type of set of tooling and instead of how I can use this efficiently. It's not like I'm using like new versions. I'm using very obscure piece of technology that maybe the models were very vague understanding. I'm in the world of Apache Spark, Apache Flink, Kafka, and all these kind of things, and I try to weigh how I can build like Kafka and Flink applications. It was not easy until we
discovered one of the most amazing MCPs, model context protocol servers out there, called Context 7, and those guys provide up-to-date docs, APIs and context samples for any technology in the world. And the way they do it with any technology in the world, you can give them either GitHub or a website with examples and documentation, and they will expose it to your models through MCP protocol, model context protocol through MCP, and it will learn whatever you needed to learn on the spot. It works amazingly, and there are other ways to do it. For example, Simon Maple, our friend in Tessel, they do something very similar with their spec-driven development. So there is something that they call the spec registry, which is basically the same. It's a library of known documentation that will be downloaded to your machine machine for your tool to use, and then suddenly there is no such thing technology that it didn't know.
Yeah.
Even more so, we actively instruct it against using any previous knowledge.
Yeah.
Right? We start with you know nothing, Jon Snow, about this
Yeah.
technology. Only use context 7 to get the right information, and then it's magic.
Yeah. So when you writing your prompt, it's again the part of the prompt engineering basically. Every time when we're trying to build some frameworks, go and check documentation, check how the certain classes, for example, the good example, REST template versus REST client, which new class in Spring recent versions versus REST template that is deprecated. They have some knowledge about REST template, but we want to say, okay, so you don't have any knowledge. Go there and research this, and it definitely changed a lot. So that's why we start seeing like less confusion, less hallucinations on the model, and compilation errors. It's just gone.
Yeah.
No, like seriously, with the right documentation, right code snippets, and we know that the Spring AI has great documentation about the Spring AI. Spring Boot has a lot of good documentation. It just need to matter of like attaching correct documentation bits, and the context 7 solve this problem.
Yeah.
You don't need to build your own RAG to do semantic search or like a vector search of these things. It's already handled on context 7 and exposed in the MCP protocol to any model. Whenever IDE supports MCP, I think that's essential. If you're releasing new IDE or new agentic coding tool, you need to have to support this, because otherwise it's useless. You will be very far behind until you have this implemented.
Stephen Chen. I work at Neo4j, which is a graph database company, and I'm going to be chatting a bit about building applications using agents, using MCP servers so you can abstract out tooling, and then also GraphRag, which is a way of improving on retrieval augmented generation by using graph databases as the knowledge layer.
What's the difference between a graph database and MySQL?
Fundamentally, relational databases store things in rows and columns, so they're tabular data. Graph databases store things with nodes and relationships and properties on nodes, so they're a more flexible structure. Typically, also, relational databases require a schema to get started with. Graph databases are schema optional, so you can start with the schema if you want to, but you can also just start to populate it with nodes and relationships. And
So they can grow more easily, let's say.
exactly. And for AI use cases, in general, the large language models are quite good at constructing knowledge graphs. So you can ask them to build out a knowledge graph from a set of documents, from other structured data sources. You can ask them questions about the data using a knowledge graph, and they'll actually do searches and write cipher queries. Cipher is the equivalent to SQL for relational databases, but for graph databases. And it helps to kind of ground the LLM. If you tell it only answer using the graph database as the knowledge source for a question, then you can get more reliable and accurate results coming out of the LM than if you let it kind of pull out of a vector database, which is kind of a black box, it's opaque, or if it can't find the information and it starts to kind of hallucinate or pull information from its general knowledge store.
So is such a database better for AI use cases?
It depends on what your use case is and what you're trying to do. Actually, what a lot of companies are doing is they'll use graph databases together with vector embeddings. And so one strategy is you populate all your vector embeddings. You can actually put those embeddings as properties on nodes in a graph. And then when you query the vector side and you get back some results, you can see which nodes come up highest on the list, and then pull out related nodes from the graph databases using cosine similarity or community grouping algorithms. And then you have a larger, more relevant set of results to pass as context to the LLM and answer from than if you just gave it the vector embeddings will give you similarity rankings only. So they're useful, but usually it's incomplete. Like you won't get a full set of results back. And sometimes you'll get back results which are similar but unrelated. Like, you might get back fruits when you ask about Apple, the company, rather than other companies, other tech companies in the same space.
Yeah. You have a talk about this subject. What's the main thing I should remember from the talk?
The big takeaway from the talk would be when you go to your friends and you try to explain to them what MCP is, because I think everyone's implementing MCP servers or using MCP servers that vendors provide. Don't use the standard USB hub analogy because it's boring and overused. And instead, a great way of thinking about MCP servers and agents is agents are like super robots that combine together, kind of like Ultron or those like historical ones where you get better with more agents, more powerful. And MCP tools are like the weapons, like the swords and the weapons that you use to kill the bad guy at the end of each episode. So that's a much better analogy for agents and MCP servers.
All these things are evolving so fast, but do we already have future-proof workable solutions there, or is a lot of this still experimental?
Well, obviously it's experimental because a year ago it didn't exist, right? I think the MCP spec came out November-ish last year. But I think that's quickly moved towards practical, people are actually using it in production and applying it. Agents came out earlier last year, but I would say the patterns for the best ways of using agents and how you use them with new language models and the LLMs keep evolving. That's kind of a moving target for the best use case for agents. But it has quickly become the best practice for how you build AI applications you want to put in production.
A lot of people probably don't realize, but if you're now using IntelliJ IDE and asking some questions to their chat-based approach, then it actually does a lot of MCP calls already behind the scenes.
Yeah, and you can add your own additional MCP tools, which you want to use as well. And it is, I think the fact that it's exposed to developers, where you're using MCP servers as you write code, is helpful because it's also the best way to write your application, to have an application where you're breaking out services and databases and APIs as MCP calls rather than doing a hard coupling where the LLM is directly accessing resources.
Yeah. So it's another way of exposing your knowledge or the data which is inside your business to make it questionable, something like that, so that you can ask questions on top of your existing knowledge.
One of the demos I'll show tomorrow is using a standard lookup, using a vector database versus using MCP tools, which can query the database schema, can kind of navigate the graph with multiple queries to search for the information it wants. And the answer you get back from the MCP approach actually is a more thorough response than what you get back just by looking up the vector embeddings.
My name is Fusco, and I have done quite a few editions now. Speaking about different topics, I started more than 10 years ago. It was the time when Java 8 introduced the Lambda expression. So my very first talk were about how to do functional programming in Java, and then I focused more on my day-to-day work at time was on Druch, so the rule engine of Red Hat. So I also had a few talks on this topic. Let's say the old-fashioned AI, the AI before the LLM, was this rule engine thing, and then another area where I gave a few talks is when they introduced the virtual thread. So I did a few talk about the concurrency as well. And nowadays I'm totally into this agent and AI stuff, because if you don't, you are out of the world for some reason. So I'm doing this, and today I'm mostly participating to demonstrate the work that I've done in the LangChain4j framework.
So LangChain4j is one of the main Java ways of doing AI and LLM in code.
At the moment, yeah, as far as I know, yes, it's by far the mostly used framework, and it is well integrated with many application frameworks. So, okay, I'm a Quarkus contributor, so I also do the Quarkus extension that integrates LangChain4j. But if you are doing Spring or Micronaut, you can have some easy integration path as well. Yes.
So what does Quarkus offer if you combine it with LangChain4j?
It offers a more declarative API in general. So instead of programmatically creating your AI services or agent, you can wire them with annotation in a more programmatic way. It offers CDI, so you can have the automatic injection of the agent, of the chat model and stuff like this. And so the wiring is much more simple. And offer, of course, a lot of the enterprise feature that you want when you actually put this stuff in production. So you have observability, you can trace how many time an agent takes and how many times it is invoked. It offers some security features and so traceability and all the things that you may want to use in an actual enterprise project. Yes.
You have quite some history you just mentioned in Java. How do you look at what the AI changes are now bringing to how we develop applications?
You mean this vibe coding thing?
Well, I don't like the vibe coding myself. It generates too much fluffy stuff.
Yeah.
But can we do more things and other things if we use these tools now?
If we use these tools carefully and without ever turning off our brain. I mean, it happens. I'm honest. It happens quite often now to me that I just wrote the signature of the method, and if I give a meaningful name for the method name and for the arguments, it generates the body of the method for me. And sometimes I'm surprised because it really seems that it's reading my brain. I mean, since you have the project in the context of the LLM, what impresses me sometimes is that not only it generates the code, which is mostly correct, but it also follows my style of coding.
Yeah.
How I use the new line now, how I
the way
do
you
blocks.
write,
really the same style. It really seems that I wrote it myself. So that surprised me. Sometimes it seems that it reads my brain. Some other times it's a totally failure. So. But it's a tool and it's a boost for your day-by-day work. So I use it daily, yes.
It's not a developer replacement, it's a developer tool.
Yes, yes.
And use it as such.
So I really appreciate what Stefan often said, is that you will not replaced by AI, but a programmer that uses AI as a tool.
He knows how to use these tools, as you talked about Java streams and virtual threads, what are some of the ongoing improvements within OpenJDK that you're really looking forward to that they get?
Well, the things that Paul Santos mentioning this morning are really exciting. I mean, really we need a way to leverage GPU from inside Java. Otherwise, it's impossible to run inference of big model from the JVM. So I'm really excited about this FFM new API and the work they are doing with Project Babylon and Project Panama.
It's a bit surprising that these two projects now seem to help to run AI-based tools in Java while they started.
Yeah, okay.
Even before
they started. Well, this happens quite often in our field. I mean, you start doing something for a totally different reason, and then it becomes useful in an unexpected way. So, yes. I believe, I mean, it's a combination of intuition, but also luck. I mean, think about NVIDIA, right? They start doing graphic cards just for gaming. And then it comes the blockchain, so people who starting buy graphic cards, but just to do the
mining.
Bitcoin, the mining, that stuff. And then they have been lucky for a second time because then it started this Gen AI craziness and people start buying graphic cards, but to do Gen AI. So it's, I don't know, it's called serendipity, I think, but yes.
And the same for Tornado VM, which is already working
That's
for 10 years or more to run Java on GPUs. They are now
they find the perfect application. Yes, yes, I'm following them, and we are working with them that they have a module to integrate Langchain4j with Tornado VM. So that's really interesting. Yes.
You're a speaker, so you have talks. What's the most important fact people should remember if they join one of your talks? If you can pick one.
Well, this year I'm mostly speaking about Langchain4j. The message that I want to convey is that you know, it's not black or white. There is a whole spectrum of possibility. You can have agent that create a plan, or you can create your own plan and coordinate agent, and everything in the mix of the two. So my message for this year is that there are lots of amazing possibility with this Gen AI, but you really need to know what you are doing. And this afternoon, indeed, I gave with a couple of colleagues a talk not about how my stuff work now, how the new agentic module of Langchain4j works, what it does, but how we get there. So it's more about the journey than the destination, and the journey is very interesting because again, we figured out while working on this that there is not, so maybe this is really the message, especially in this field, there is not a solution that fits all problem, but you really need to be critic and figure out what's the right combination for the problem at the end.
So you're talking about agents a lot. Can I create an agent for simple tasks, for instance with Langchain4j? Is that a bit the goal, to isolate problems into single tasks that you can assign to an agent?
So one problem with big LLM, and if you not only with big LLM, but if you give up a big task to it in one shot, is that the probability of hallucination increases a lot. So what you do and what it works for us is that you try to split the task in a smaller step, and maybe you can have an agent with a model that is specialized for a given field. For instance, I was speaking right now with friends that work, they does medical software in Switzerland, and they are using now specialized model, of course, to check, to find cancer or to find specific disease in some pattern. So you really need to have specialized model. You really need to break your problem in smaller tasks, and then of course, and this is what the agentic modules give you. You need a way to coordinate all these agents. You need a way to have to run this task in a workflow, let's say.
That's what we already discussed before in another interview, is that one big LLM solving everything is
Well,
almost impossible.
It's almost impossible, and again, it increases a lot the possibility of that something can go wrong. Yes.
So if you can create an MCP or have some data source with the truth about a specific subject,
Yes.
that's a better source.
Or now there is A2A, so you have remote agent specialized for specific task, and you can connect the remote agent, and you can mix local agent that you do specialized for something, and a remote agent that you know that is good at another task, and you can mix these two things in one single big agentic system.
And probably is also better for businesses who have very critical data or personal data, that everything stays inside your company.
Sometimes, and this is another winning point for local inference, for instance, in Java, because sometimes you want to send your data to a big LLM, but by doing so, you are also sending your data. So probably in many cases, it's said, for instance, for the medical situation, you don't want to do this. So you want to have local inference, you want to run that model locally, and that's the exciting part of Project Panama, because they allow you to do this directly on the JVM. So that's nice.
So a lot of ongoing evolutions which will make this even better.
But you see, pieces are coming together in a way or another, so that's nice, yes.
My name is Jeroen Benckhuijsen. I work for Group 9, and I'm visiting here just to see some talks, and also working on our stand to show us to the people over here.
Okay. What is the most fascinating change in Java for you in the recent years?
Oh, Jesus, what a question. I've come a long way back since I started with Java. I think I started around the 1.3, 1.4 era. So in the recent years, the whole functional programming paradigm is I think a huge change. That first of all, and I think the whole change I'm working a lot in enterprise development. The whole working way more lightweight, offloading stuff to the container. So just reducing your application footprint is a huge change, I think.
Is it reducing to reduce costs? Is it reducing to make it smaller in maintenance?
I think smaller in maintenance mostly. I think what you see is that there's quite a few logic for which we previously had our big frameworks, the Java infrastructure, etc., which is now largely offloaded to stuff like the container, Kubernetes, mostly infrastructure layer. So we can basically focus in our own application way more on just the core business logic instead of building a whole lot of technical code, which is still fun to make, but it's kind of offloaded, and that's a nice change to see.
Is that a bit of change in how applications are developed?
I like it actually because it allows me to most of the applications I work on are quite difficult on a functional level, and you need to really communicate with your business analysts, with your quality assurance people. And if the code is way more easy to comprehend for them because it's just business logic, that makes it way easier to talk about. Is this the correct thing that we want to implement? And it makes for a really nice separation of concerns, so to speak, between the technical stuff and just the core business logic. So that's nice.
Do you see any change related to AI and auto-generated code? Because you say you really need to understand the business.
Yeah.
Is that not the real strength of a good developer? That you can translate a business problem into code?
I think it is. I mean, I'm quite still curious what the whole AI transition will bring, because if it is just having another layer on top where we speak sort of structured English instead of Java, then a lot of work is still in understanding the business, understanding the user, in what do we want to achieve. I think you see quite a trend where, again, technical logic is moved away from the application. So that's stuff that we don't need to build anymore. Spring Boot and stuff like that just automates it for us. And you can really focus on that core logic. And understanding that is, to me, always a core quality that a good developer has. Not just being able to write good Java code, but also really having a good understanding of the business, being able to comprehend the business domain. Yeah.
A lot of talks today.
Yeah.
Did you select the ones you definitely want to see?
I have a set of talks which I definitely want to see. I missed one because I also have to do a bit of stand stuff. But I was interested in the Java 25 stuff. I mean that's just basic housekeeping to keep up to date with that, of course. And there were some nice talks also on Project Valhalla, on Babylon, the integration with the GPU that I liked. So yeah, quite nice talks that I wanted to see. Yeah,
I talked at Devoxx with the people from the Tornado VM who also do that kind of stuff, bringing things from Java to the GPU.
Yeah.
You have use cases for that?
No, that's mostly. I think I'm working mostly in enterprise development, so there's not a real use case for that. So that's mostly just hobby and being interested in that stuff. Yeah.
But is that the fun thing, that the boring business application stuff we can do with Java, we can also do a lot more.
Yeah.
And we can do this kind of fun stuff. I experiment a lot with Raspberry Pis.
Yeah.
You have this whole evolution of trying Java on other CPUs, and
exactly.
RISC-V is there also around the corner, other processors.
Yeah.
Shouldn't we just play more with Java even?
I mean, it's. I think that really helps. Just playing more with Java makes you really help with getting a real understanding what's going on the hood. Where can you use Java? What are the strengths? What are the weaknesses? So, and it keeps working in Java fun. I mean, work is still work. Work is. I like my work, but it's. Just doing business stuff can be boring, and it's a nice change of work. And
to learn indeed what's happening in Java.
Exactly.
New APIs which are available.
Yeah, and I think what also helps is if you do that stuff, it might give you inspiration on how to use that weird stuff in a business sense. I mean, I think a month back we had a discussion at our own company on how to use reinforcement learning. So not the whole mumbo jumbo around large language models, but just look at it from another edge and try to think about how can we use the more core AI principles in a business environment, which is kind of hard, but it's first innovation. It's first thinking about real other stuff, and that's in the end I think our job is in the end is a creative job. I mean, it's not just programming; it's being creative. It's thinking about stuff and doing other stuff that helps that process. That's the fun of it. Yeah.
I'm Martijn Dashorst, and I am a speaker.
Okay, and the topic?
The topic was catching the 137 killer.
Oh, and that's
a serial killer that hunts for JVMs in your Kubernetes cluster.
And why would it kill my JVM?
Because your JVM wants to use more memory than is allowed, and then Kubernetes says no, and it doesn't ask nicely. It just kills your process.
Okay. And what can we do about it? Is it just a configuration? Did I do something wrong in my codes?
Oh, that's the case. The presentation is a talk about an investigation on what you can see and what you can use to figure out what is killing why your application is being killed. In my journey for this presentation, I could not find a culprit. I looked in Grafana, in our logs, heap dumps, Java native memory tracking, and I couldn't figure it out what was happening. So. And that's the fun of this of giving a talk, right? You learn a lot, and I learned quite a lot. And yesterday evening at 9 p.m. I probably found the actual culprit. I gave the talk previously on another conference, and I reached the wrong conclusion there, and I figured that out the night before as well. So that's very stressful. Having a presentation ready to go and then discovering, oh well, my last 15 slides are completely wrong.
Is wrong.
So, unfortunately, yesterday evening, probably we found the thing, and with the help of large language models that helped analyze the native memory reports, and it was just
a lucky strike. I trimmed the native memory of my JVM application, and I put that in the report together with the native memory tracking report. So let's see if it can find it. And it said, well, okay, I found it.
Java being killed, is that why for people who are watching this podcast instead of listening, is this why you brought the Duke being killed by a big knife?
Yeah, I like Duke. It's a really nice mascot, and I got this Duke way back.
It has a label by Sun.
It has a label by Sun, and Sun is not all around for a long time anymore. And so my wife is very crafty, so she made him a murder victim. And
but as you said, we have logs, you have heap dumps. I guess if a Java process gets killed, you won't see that in the logs.
Nope.
The reason, no.
No, so the out of memory, that's one of the tips in my presentation. Of course, watch the presentation because it's a really good one. But I'll give this tip. What we did is, if you have an out of memory kill, the process is gone, and you don't see that in the logs, other than that your log stops. You have no recourse, so you can't take a memory dump. There's no chance for a heap dump to be created, etc., etc., etc. So one of the things I focused for a very long time on. But if the out of memory kill comes along, what is the status of the application at that time? And you can't figure it out because the process is no longer there. So a coworker of mine said, well, if we just increase the pod memory and limit the JVM to be
lower,
much lower than that, and then just see what, and then you still have the process, and you can figure out what is causing the memory issue, what grows beyond what the limit is. So that was really nice. I also exacerbated the behavior of the program to shorten the time span in which the
before it happens.
And I limited the memory use really low to see if it could fit in a very low memory profile. And that, from there on, it still was not visible in any of the dashboards, in the memory heap dumps, etc., until I did the trim of the native memory.
Yeah.
And the large language model came with, but then you need to fix these 3 parameters for glibc, so that's the memory library that the JVM uses, and then it should not fragment your memory as much. Yeah. And I never heard of those parameters. So, and I would not know to Google for it.
Because you don't know that they exist.
So, the large language models have really a big benefit for figuring out stuff you don't know.
Yeah. Such a very technical, deep problem. I guess it's unique. You don't have this every day with different kind of applications, I guess.
No, this is a very particular application. It spans 150 threads to do a crawling, a spider for status information of our tenant systems. I implemented it very badly. It's a very naive implementation because, well, and the issue was not, I know how to fix it, right? I know how to fix the application that it would not run out of memory, etc., etc. So the exercise was, can I find the tools and all the dashboarding and such to analyze this problem.
And to find the specific problem.
So that in other cases I have the tools readily available. And that was the exercise, not fixing the application because the memory is cheap, so we could just give it, I don't know, twice the memory it needed, and then it would run indefinitely.
Is that the nice thing about Java, that all this memory handling, we can just ignore it? It happens behind the scenes?
For the most part, yeah. Unless you're talking about native memory, which is hidden from you completely.
Yeah. Is this a problem you would only have in a Kubernetes closed environment, which makes it even harder to get to logs and to states of applications?
I found it quite easy to get to the running process actually. typically, if you deploy on virtual machines and such, then you have to SSH into the machine. You have to enable your VPN and such. And if it runs in your Kubernetes cluster, you can just go to your open lens thing and then say, "Oh, give me a terminal," or use kube control to issue commands directly to your container. This issue is the memory leak is always present, of course. Is it a thing that manifests itself in containers? Anywhere where you put a hard limit on your memory, and if the hard limit is fairly close to your actual process usage. So if you say, I have 1 gigabyte of extra RAM assigned, well, then probably you will never see it
fixed.
My name is Maarten Mulders. I've titled my talk, "I'm not afraid AI will take my job," because I'm convinced it will not. But we can't close our eyes. It will change our jobs for sure.
If it already has.
If it didn't do already, then it will. But I think for many of us, it already happened. I see people around me using large language models to answer simple programming questions, to even fill in pieces of code that they are like, I know exactly what it should look like. I want it to be there, and you probably
lazy.
know.
Yeah, a bit lazy.
Yeah, well, lazy has this negative vibe around it, so I'm trying to avoid that word. But yeah, it's a bit of a laziness. Like we both, you and I, we both know what should happen. Maybe a better analogy. They use large language models and the tools around it to delegate work to the work that they know pretty well what should happen, what the code should look like, as if they had a junior programmer next to them, an intern maybe. They can coach it. They can provide some guardrails. And no, you shouldn't be doing it like that. But if you do it that way, it looks better. So for those situations, yes, it helps. But on the other hand, if we weren't aware already, AI isn't that magical device that will solve all our problems. If only it were, but it isn't, and we should pretty well be aware of that too. Use it where it makes sense, but know that there are many cases where it absolutely does not make sense.
You're not a believer of AI will generate all our codes. It's not capable of doing that yet, or it will never be capable of doing that?
It is not capable yet, and I seriously question if it ever will be. I think that a part of our job as engineers is finding good solutions that fit within the problem space, within the context that we're operating in. And some of these things maybe you can tell them to a large language model and give that to them as to the tool as a guardrail. But sometimes there are these nitty-gritty details, let's call them that way, that highly influence your solution. And it's very hard to make tools aware of that. And that's especially where I think we, as humans, provide the additional brains, but really literal brains, that can fine-tune for the particular context that you operate in. And then there's obviously the kind of projects that we might work on that, well, we are doing something fundamentally new, something that no one has done before. And what is a large language model good in? It is good in repeating what it has seen before. But if I'm doing something that no one has done before, who is it going to copy?
As a developer, you should not be just coding. You're fixing a problem. So first you need to understand the problem, and then you can find a fix for it. And that's where I think where AI is not even involved in finding the real problem.
Let alone figuring out what a proper solution is. But if we know the solution, then we can ask a large language model, hey, I'm looking for this kind of a solution. It looks like that. Take this as inspiration. Take that as an example. Model it for me. Code it for me. And I'll be the one that's reviewing your work. I'll be proving if that code should be shipped to production, yes or no.
If you look into OpenJDK evolutions, Java 25 now being released, what's one of the main changes happening within OpenJDK, or that already happened?
I'm really enthusiastic to see that the language is still evolving. I have a lot of colleagues who work on .NET, and they kept making fun of those Java people. When will your language finally have this or that feature? And I think one of the great things that we see now with the increased release cadence is that Java is really catching up and adding lots of new things, and things even that other languages may not yet have, or yes, well, we have it, but differently. So that I think is in itself already great. And I also like the fact that from a platform side, a lot of effort is going into even further optimizations, like smaller objects, like improved startup times. You could say after 30 years of engineering, the JVM is a established product and it's done, don't touch it. But no, we keep on improving, we keep on getting the last bits of performance squeezed out, and I think that's amazing.
It's not the language only which evolves, but it's also the runtime, which contains a lot of changes with each release.
Yeah, that is really amazing to see, and we don't often see it. But when I was preparing the talk about improving your Maven builds speed for this year's Devoxx, I noticed a funny thing. We had been running demos with Java 17 and then Java 21, but with Java 24, there was a significant improvement in speed just by using a later Java runtime. Free performance gains. Who doesn't want that?
And that's why people should actually consider moving to each new release. I know for big operations that's a bit difficult.
And let alone all the security improvements that we see. But there's enough reasons to stay up to date. And I think, especially the last few years, it hasn't been particularly hard anymore. Sure, when we were on Java 8 and Java 9 was introduced with the module system, of course that was a big hurdle, and not all libraries were compatible and whatnot. And many, many reasons. I totally understand. I was there just like yourself. We've seen it, we felt the pain. But it isn't that case anymore. Now it's often a matter of changing 24 into 25.
Building and
maybe at 4 places, but that should be it, right? And then very small chance that something breaks. But I haven't seen any examples recently. Have you?
No, absolutely not.
So my name's Simon Maple. What brings me to Devoxx? I've been a long-term kind of Devoxx fan. Done many presentations for Devoxxes all over the world. So actually the company I'm with now, Tessel, new startup, and once we launched, it's like, we've got to be at Devoxx Belgium. Let's do that.
And what are you doing with the company?
So the company is a newly founded company. It's only 18. I say newly founded. It's 18 months already, but we only launched a few weeks ago, and it's really looking at how some of the amazing new AI technologies, while being amazing, can we actually harness them in such a way where we can reliably use them in a more spec-oriented, spec-driven way to provide to go the next level beyond vibe coding and actually have something which is more production ready, more verifiable, more something that we can validate very deterministically. So it's all about how spec driven can take us to the next level with AI.
So you are using AI on the developer side?
Absolutely. It's all about developer workflows, and of course, trying to look at it a little bit more natively. So we're trying to think about AI native and what that means. So ultimately, if the developer environment were to be looked at from the ground up again, using AI as a core first-class citizen, how would that change what we do? And we lean into specs more. And while, from my personal developer point of view, it kind of like moves me a little bit further away from the code. It's definitely remains that creativity, that developer, almost architect style creativity around how things should be designed, how things should be built and organized. But that's the model we're aiming for.
So AI is great. I use it a lot for experiments. Give me an example of how I can do this. But building something completely AI-driven is a bit far away.
It's very challenging. We love agents. Agents are very, very powerful. There are a number of ways in which agents can kind of like fall apart, though. I'm sure we've all your listeners have kind of like fallen into the trap as well, where they make one change and actually it affects several other things. Like there's collateral damage across the application. Sometimes it spirals and just can't get the thing right because it doesn't have it in the knowledge base. It doesn't have the right context. So there's a ton of things that we're trying to do that kind of, first of all, makes agents more reliable, more accurate. So we're trying to provide a registry of specifications, completely open beta right now and completely free to use. And the idea is these specifications describe how an agent should use libraries. Yeah. So open source libraries, each of them have specifications by version, and that specification describes the APIs that exist, how to use the APIs, examples of best practices of using those, and then when that information then gets sent, it actually gets installed on the machine, which just essentially means downloaded onto the local file system. We spawn off a little sub-agent, which then, based on the request you ask, takes the right context from each of those usage specs and passes that as context to the agent, the main agent thread. And that main agent then has a greater chance of being able to accurately write code, generate code, based on the fact that it's connecting with these APIs. Exactly, yeah. So without that, agents can code against the wrong versions or hallucinate APIs far, far more easily.
How are you looking at all the evolutions now, not only on developer side, but also what you can do in your application with AI?
It's amazing, frightening. It's all of these. It's like, I think one of the things, particularly working in a company that is using AI, I've never seen anything travel so fast and through an industry as what we're seeing right now with AI. I think there's definite being people wanting to be able to run before they can walk, and I think is absolutely imperative that when we build with AI, both in our development processes and our applications, we do so with that sense of understanding of the fact that this can generate anything at any time. Which is obviously during runtime a little bit more challenging, but we can add guardrails in, and I think guardrails are the key to not just effective, but any kind of reasonable AI usage. In development, tooling is one of the best things we can do. We can use to make sure that we are guiding the processes at the best of times, but also recognizing what we need to do better from a code review point of view, how we don't burn ourselves out from just being code review machines. But also these guardrails that we can add in through tools in runtime as well. Guards that effectively are points which validate input, validate output. You give it material that you are happy for it to spill, all of those types of things. So it's incredible what it unlocks, but it's very challenging to make sure we use it morally, ethically, and without security issues and those types of things.
And not trusting it blindly.
Not trusting it blindly. I mean, everything. A lot of people say treat an AI like a junior developer. Whatever it puts out, would you put that to production? It's like they are your brand. If you put them in your app, they are your brand, and so whatever they share, you've got to be valid. You've got to stand behind it, and so you always got to make sure there's either some level of human touch at that point when something critical is going to happen, or you put the guardrails in so that it can't do things that are potentially damaging to your company, your brand, etc. If it gets the chance.
And that's a wrap for this episode of the Foojay Podcast. Thanks to my guests for sharing their stories, and thank you for listening. The big takeaway from all these conversations: AI is really helpful, but you can't just blindly trust it. You need to understand what's happening, ask the right questions, and know when the AI is giving you something useful versus when it's just making stuff up. The Java world keeps evolving. We're getting GPU access through Project Panama, performance improvements in every new JDK release, and better tools for working with AI. But the real skill is still about solving problems, understanding your specific situation, and making good decisions, not just letting an AI generate code for you. If you enjoyed this episode, please subscribe to the Foojay Podcast on YouTube or in your favorite podcast app. You can find all our episodes, show notes, and links on foojay.io. Follow Friends of OpenJDK on social media to stay up to date on what's happening in the Java community. Until next time, keep coding, keep learning, and remember, AI is a powerful tool, but your brain and experience are what turn code into something that actually works. Thanks for listening.
Give me a foo, give me a J, give me the friends of OpenJDK.